I want you to stop whatever you're doing for just a second.
Just pause for a moment.
Right. Just pause. And I want you to consider a remarkably simple, completely everyday action. You're holding your phone, or maybe you're sitting at your laptop, and you hit send on an email with a really heavy attachment.
Like a big video file or something?
Exactly. Let's say that email is making a trip across the Atlantic all the way to London. You hit the button, the little progress bar fills up, and it's gone.
Out into the ether.
Right, out into the ether. We all know the basics of how this works, you know? As an informed user, you're already well aware that your data isn't just floating through the atmosphere on some magical cloud.
Or riding on some magical space Wi-Fi.
Yeah, exactly, space Wi-Fi. We know that subsea cables are the actual backbone of the internet. We all know they exist. But we suffer from this profound out-of-sight, out-of-mind bias.
Oh, absolutely.
We think that once a massive, localized fiber optic pipeline is dropped into the Atlantic, it just it just sits there, happily transmitting data forever.
It's a really natural cognitive shortcut, honestly. The entire user experience of modern technology is engineered to make us feel like our data is completely detached from the physical world.
It feels weightless.
Right. Your devices are sleek, the interfaces are super minimalist, and the physical friction of communication has been deliberately erased from your daily experience.
Yeah.
Because of that, we tend to view the physical infrastructure of the internet as permanent. We treat the seabed like this magical hard drive that never degrades, never needs maintenance, and never runs out of space.
And that is the exact illusion we are breaking apart today. Welcome to The Deep Dive. I'm your host, and I'm here with our resident expert to look at a stack of really fascinating excerpts from a piece called Subsea Spirits, The Raising of TT-8.
It's a great piece.
It really is. The mission of our deep dive today is to shatter that illusion of a wireless internet. We are going to explore the gritty, highly physical reality of how our global data network actually functions and more importantly, how it eventually gets dismantled.
Because it does get dismantled.
It has to. So, okay, let's unpack this. We're looking at the massive logistical nightmare of what actually happens when that physical infrastructure becomes obsolete and has to be torn down.
Yeah, because the reality of maintaining and eventually dismantling thousands of miles of subsea infrastructure is far more complex than just, unplugging a router in your living room.
Totally.
To really grasp the scale of this challenge, we need to acknowledge the fundamental engineering tension at the heart of this source material. We're dealing with a stark contrast between the invisible, weightless digital world you interact with every single day.
The cloud.
Right, the cloud. We're contrasting that with the incredibly heavy, sprawling industrial footprint that actually makes it possible. 99% of all international data traffic travels through these underwater pipelines.
99%. I mean, that is just a staggering metric.
There really is.
When you say 99%, you are essentially saying that the entire modern internet, for all intents and purposes, is a heavy maritime enterprise.
It is entirely an industrial maritime operation.
Reading through the text, the sheer physical weight of that enterprise is what really stands out to me. The source uses this great analogy. It describes the internet as a physical garden hose made of glass.
A garden hose sitting right on the bottom of the Atlantic Ocean.
Right. We aren't just talking about a delicate thread of glass resting on the sand. We are talking about heavily armored subsea infrastructure. When you send that email to London, it is traveling through a highly engineered, multi-layered pipeline resting in the deep, dark mud.
Under miles of water.
Miles of it. It's an industrial reality that feels completely disconnected from the sterile, clean glass of the smartphone in your hand.
And the reason that heavy, physical, old-school infrastructure is still entirely current school is purely mathematical.
Explain that a bit more.
But we often associate progress with moving away from physical tethers, right? We assume everything will eventually go wireless or rely on low Earth orbit satellites.
The space Wi-Fi.
Exactly. But physical glass fibers can carry vast, unimaginable quantities of data via light pulses far more efficiently, securely, and quickly than beaming radio waves through the atmosphere.
It's just faster.
Way faster. The latency and bandwidth capabilities of a physical light pulse traveling through a purified silica core, it simply cannot be matched by wireless transmission. To get the immense data capacities required by global financial markets, streaming services, all of it, engineers had to continually double down on laying more physical lines across the most hostile environment on Earth.
The ocean floor.
The bottom of the sea.
So the oceans are still the great geographic barrier. We traded the copper wires of the old telegraph days for advanced fiber optics, but the fundamental geographic reality never actually changed.
Not one bit.
We still have to bridge that physical divide. Which leads us directly into the specific subject of today's source material. The text focuses on the retrieval of a very specific cable, one that it calls the grandfather of all these subsea lines.
TT8.
TT8.
It is a piece of technology that absolutely deserves that pioneer status. The source details exactly why this specific cable is so historically significant. TAT8 was the very first transatlantic fiber optic cable laid down back in 1988.
1988.
Yeah. And at the time it was activated, it was an absolute marvel of modern engineering. It could carry roughly 40,000 telephone channels simultaneously.
40,000, which sounds like a lot.
To the engineers in the late 80s, that capacity felt virtually limitless.
But 40,000 channels was revolutionary then. If you look at the specifications of the newer cables being laid down right now, it puts that number into a really harsh perspective.
Oh, it's not even close.
A single modern subsea cable can carry roughly 4 million times the capacity of TT.
4 million times. Let that sink in.
It is not just that TT8 is old. Mathematically, it is entirely, completely obsolete. It cannot keep up with a fraction of a millisecond of modern data traffic.
Which introduces the core problem we're discussing today. Progress marches on, and the grandfather is no longer useful. But you are dealing with thousands of miles of engineered material lying across the Atlantic seabed.
You can't just leave it there.
Exactly. You cannot simply leave it there forever. It becomes an issue of physical space, environmental responsibility, and international maritime law. Abandoned cables can interfere with newer infrastructure.
They get in the way.
They do. And they can become environmental hazards as their casings degrade. Plus, the seabed itself is a finite resource in heavily trafficked data corridors.
So crews are literally ripping TT8 out of the ocean floor right now. It is this massive project of recycling the internet. And recycling a transatlantic cable isn't just a matter of reeling it in like a fishing line.
Not at all.
The logistics described in the source are mind-boggling. You have enormous specialized retrieval ships sailing out into the deep ocean. They have to locate the specific line, which has been buried in mud and subjected to deep-sea currents for decades.
Finding it is a feat in itself.
Right, and then they have to drag a grappling hook along the bottom to catch it and physically hoist it miles up through the water column.
And what's fascinating here is the physical tension involved. Think about the life cycle of technology. When the physical backbone of the internet becomes obsolete, the mechanical friction of bringing it back up is immense. You are hoisting tons of material through miles of ocean currents.
The sheer weight must be incredible.
It is. The tension on the retrieval line is extraordinary, and the risk of the old degraded cable snapping under its own weight is a constant threat during the entire operation.
And once you actually get it onto the ship, the recycling process is its own industrial nightmare. You aren't just melting down a single piece of plastic.
No, it's highly complex. The recycling plants have to systematically separate the raw, copper tubing that carried the electrical power, the high-tensile steel armor that protected the core, the thick layers of polyethylene waterproofing, and the glass fibers themselves.
So the raw materials can be repurposed.
Exactly. It's an intense industrial teardown.
But the vulnerability of these cables isn't just about their age and eventual obsolescence. The text highlights that when TT8 first went down in the late 80s, engineers discovered a completely unanticipated threat to the physical casing. The environment itself started fighting back.
Ah, yes.
We are talking about marine life, specifically the infamous shark myth.
I love this part. It is an urban legend that has permeated tech circles and pop culture for decades. The idea that sharks are actively hunting our data cables.
I honestly want a Jaws versus the internet movie.
It would be a blockbuster.
But the most fascinating part about the source material today is that it completely validates the origin of that myth. It wasn't just pulled out of thin air by some paranoid engineer. Back in the 1980s, during the early days of testing these new fiber optic casings, they were hauling up test cables and finding real physical shark teeth.
Literally embedded in the armor.
Perfectly embedded in the polyethylene and steel armor. You can imagine the absolute panic. You have this revolutionary multi-million-dollar telecommunications project, and it looks like great white sharks are trying to eat it.
It is so easy to see how the narrative spun out of control from those initial findings. The myth quickly morphed into this idea of cyber-terrorist sharks deliberately targeting the internet.
Cyber-terrorist sharks.
Right. People thought maybe they were attracted to the electromagnetic fields or the hum of the data like they were drawn to the signals.
But the source absolutely dismantles that cyber terrorist theory. The reality of those early shark bites is grounded in a much more practical and frankly hilarious engineering challenge.
It really is funny.
To figure out why the sharks were biting and to test new, thicker armoring, the engineers had to replicate the attacks. The text points out that sharks were not, in fact, naturally seeking out the cables to disrupt global communications.
They weren't cyber terrorists.
No. To actually get a shark to bite one of these massive subsea test cables, the researchers basically had to wrap the localized fiber optic pipeline in fish.
They essentially turned it into bait.
They turned the internet into a giant deep-sea sushi roll.
It completely demystifies the threat. The sharks were not attracted to the data or the fiber optics or some subtle electromagnetic frequency. They were simply responding to the bait that had either been applied by researchers or just to the marine life that naturally congregates around structures on the ocean floor.
Because it creates a little artificial reef.
Exactly. The early bites were likely just exploratory nips from curious marine life encountering a new physical object in their environment. It was not a coordinated effort to sever transatlantic communications.
It's just a brilliant example of how a highly technical problem sometimes requires a very primitive testing method. The engineers learned what they needed from the sushi roll experiments, they thickened the steel armoring on the subsequent cables, and the shark problem was essentially solved.
Solved with brute force engineering.
Right. But this interaction between high-tech infrastructure and primitive physical realities brings us to the most striking part of the source material. We have to pivot away from the bottom of the ocean, move up the retrieval line, and step directly onto the deck of the ship recovering Tay-8.
The crew handling this is wild. The human element involved in dismantling this infrastructure presents the starkest contrast in the entire text. We have this incredibly sophisticated glass fiber that ushered in the modern digital age, and yet the process of actively pulling it out of the ocean relies on grueling, intensive human labor.
The source zooms in on one incredibly specific job that exists on these cable retrieval ships. It is a role called the coiler.
The coiler.
When I was reading through this section, I was struck by the sheer brute force of it. You have these massive, multi-ton winches pulling the ship along the cable path, hauling this wet, heavy, miles-long line up from the ocean floor. But the cable doesn't just neatly spool itself into a perfect cylinder in the ship's hold.
It doesn't guide itself.
No, it has to be manually guided.
You have to remember, you are dealing with a material that has been sitting in the ocean for over 30 years. It is stiff, it is covered in marine growth, it is wet, and it's entirely unpredictable.
My immediate thought was, why hasn't this specific part of the retrieval process been automated? We have dynamic positioning systems that can hold a ship perfectly still in a rolling ocean, and massive hydraulic winches that can pull thousands of pounds of tension. Why do we still need human hands to guide the actual cable into the hold?
The lack of automation comes down to the fragility and unpredictability of the degraded material. If you are laying a brand new cable, the process is highly mechanized. The new cable is flexible, it's predictable, and it unwinds smoothly.
It behaves exactly how it's supposed to.
Right. But when you are pulling up a 30-year-old relic, you are dealing with a highly degraded physical object. The steel armor might be compromised. The polyethylene is stiffened by decades of near-freezing temperatures at the bottom of the sea, and the tension is constantly shifting.
So a machine would just break it.
A mechanized spooling system could easily crush, snap, or tangle the degraded cable, creating a massive, dangerous knot down in the hold. It requires human physical feedback.
Human intuition.
Yes, the ability to feel the tension, adjust to the sway of the ship, and manually guide the heavy line to ensure it coils flat and safe.
And the reality of that manual guidance sounds absolutely punishing. The coilers are stationed down in the massive, dark hold of the ship. Their entire job is to physically wrestle this heavy, wet, unpredictable pipeline and walk it in endless expanding circles.
The nonstop.
Round and round the hold, hour after hour, manually placing the cable so it stacks perfectly as it comes aboard. I kept thinking it sounds like the worst CrossFit workout ever.
It really does.
You are in the belly of an industrial ship, breathing in the smell of diesel and decades-old ocean mud, constantly adjusting to the roll of the waves, fighting the physical weight of obsolete technology.
Just consider the sheer physical repetition and the mental endurance required for that task. What stands out to you about that? To me, it highlights how tethered our advanced digital spaces remain to the physical world. The abstract concept of the internet, the seamless transfer of data that we take for granted, is ultimately grounded in dirt, sweat, and intense industrial labor.
The source drops this one memorable detail about these coilers that perfectly encapsulates that gritty reality. It notes that the crew members walking these endless circles in the hold, actively dismantling the grandfather of the internet, they don't measure their grueling shifts in hours or minutes.
No, they don't.
They measure their shifts in cigarettes.
It is such a profound detail. It completely strips away this sterile, futuristic veneer we usually apply to technology.
You ask a coiler how much longer they have to wrestle this wet steel, and the answer is about 3 cigarettes left.
It is the ultimate collision of worlds.
It really is. The high-tech, invisible digital realm that powers global finance and instant communication is actively being ripped out of the earth by laborers doing incredibly repetitive, physical work, measuring their time in smoke breaks. It fundamentally changes how you view the entire global network.
It forces you to reconcile the pristine nature of your devices with the industrial reality of their infrastructure. Your smartphone might not have a speck of dust on it, but the network it connects to is currently being hauled out of the mud by sheer physical force.
Dirt and diesel.
Exactly. It's a powerful reminder that the internet is not magic. It is infrastructure. And infrastructure requires an immense amount of physical energy to build and an equal amount of raw, sweaty effort to eventually tear down.
Let's pull all of this together and look at the bigger picture our source material has laid out for us today. We started by confronting our own out-of-sight, out-of-mind bias.
The magic space Wi-Fi.
Right. We moved past the simple acknowledgement that subsea cables exist and dived into the massive logistical reality of their physical permanence. The glass garden hoses resting in the Atlantic.
Right. We looked at TT8, a 1988 Pioneer that carried 40,000 channels, and saw how the math of modern data requiring 4 million times that capacity rendered it entirely obsolete.
Completely useless by today's standards.
We looked at the intense mechanical friction of hoisting it from the deep, separating the raw copper, steel, and polyethylene just to clear the seabed for the future.
We also examined the environmental interactions. We looked at the 1980s shark bites not as a cyber-terrorist threat, but as a fascinating engineering hurdle. One that required wrapping a cable in fish and studying deep-sea bite forces just to develop thicker armoring. We grounded the myth in practical reality.
And finally, we ended up in the belly of the retrieval ship, watching the coilers measure their grueling manual labor in cigarettes because 30-year-old degraded steel and glass is just too fragile and unpredictable to be managed by automated winches.
The takeaway for you, listening to this, is fundamentally about shifting your perspective on the life cycle of technology.
The so what? Exactly, the so what. The next time you rely on this global network to send a heavy file or stream a video, you won't just picture the final polished result on your screen. You have to picture the full life cycle. You will picture the miles of heavily armored infrastructure resting in the dark, and you will remember the monumental, gritty human effort required to maintain it, manage it, and eventually drag it back up to the surface. It grounds your entire digital life in a profound, unavoidable physical reality.
It adds an immense amount of weight to the everyday actions we take for granted. But looking at the massive effort required just to recycle Tati, the grandfather of the network, it brings up a much larger issue regarding the scale of what we are building today.
That is exactly the final lingering thought I want to leave you with, to mull over long after we wrap up this discussion. We have detailed the incredible mechanical friction, the specialized ships, and the grueling human labor required to pull up just one obsolete line from 1988.
Just one cable.
But TT8 was just a pioneer. Right this very second, telecommunications companies are laying down millions of miles of newer, thicker, incredibly complex cables across every ocean on the globe to support our ever-growing thirst for bandwidth.
The scale is expanding exponentially.
So consider the math of the future. If we are currently having to expend this much industrial energy, time, and manual labor to rip up the relatively sparse infrastructure of the late 80s, what exactly is going to happen 50 years from now?
Wow, yeah.
Are we slowly, inevitably building a massive, unavoidable underwater graveyard of highly complex materials? When the millions of miles of cables we are laying today eventually become mathematically obsolete, what will the logistics of that cleanup look like? Are we just creating an infinitely larger, impossibly tangled problem for future generations of coilers who will have to sail out into the ocean to haul our current digital history up from the abyss?
An ever-expanding underwater graveyard of armored glass waiting for the industrial retrieval ships of the future. It is a heavy, lingering thought, but a necessary one to truly understand the footprint of our digital age. And that is why we dig into these sources, to look past the pristine interfaces and uncover the massive physical realities underneath. We want to thank you for joining us on this deep dive. Keep questioning the life cycle of the infrastructure you interact with every day, look for the grit behind the digital polish, and most importantly, stay curious.